This video is going to go over the answers to the exercise on symbolizing. Here's answers for the first problem. If it said to symbolize this, if Jeff smiles, then Jeff is happy. Jeff is not happy, so Jeff does not smile. Here's what's called standard form. That's where you number your premises and your conclusion. You identify them as premise if they're premise and conclusion if they're conclusion, and you say where the conclusion came from for each conclusion. But you don't use symbols to represent the propositions. So you just say number one, if Jeff smiles, then Jeff is happy, premise. Number two, Jeff is not happy, premise. Conclusion number three, Jeff does not smile, conclusion from 1 and 2. And then when you want to represent it in symbolic form, what you would have to do is put a sort of circle around Jeff smiles and write a P over it, put a circle around, or an oblong around each of these. Jeff is happy and put a Q over it. And then you can write if P then Q, because you've assigned Jeff smiles to P and you've assigned Jeff is happy to Q. You'd write if P then Q, but not Q, right? Because it's saying Jeff is not happy, therefore not P, conclusion. And the rule here, remember, is modus tollens. As I said, you don't need to memorize the rule and assign it to the form, but you will need to be able to recognize which rule is being used. So if I had a sheet with the form modus tollens on it, and you'd need to be able to recognize that this is an instance of that form. Next one, Sally has 3 cats. If Sally has 3 cats, then she loves animals, therefore Sally loves animals. The standard form is just premise 1 is Sally has 3 cats, premise 2 is if she has 3 cats, then she loves animals. The conclusion is she loves animals. Notice I've left out the P and Q conclusion here. You should have that in there. Then over here, we assign Sally has 3 cats, P, so we put a circle around this and we write a P. We assign then she loves animals, or sorry, not then, but we assign she loves animals Q. So we have if P then Q, Q. Now I just made a little mistake in speech, but I'm going to use that to illustrate something you should not be doing. She loves animals is a proposition. She loves animals can be true and it can be false. But then she loves animals is not a proposition. It's not yet something can be true and it can be false. Similarly, Sally has 3 cats is a proposition. It can be true that Sally has 3 cats. It can be false that she has 3 cats. But if Sally has 3 cats is not a proposition. If Sally has 3 cats can't be true. Imagine if I said to you, if Sally has 3 cats, and you said false. It wouldn't make any sense. If I say, if Sally has 3 cats, what you're going to do is wait for me to complete my sentence, or wait for me to complete my statement. So while Sally has 3 cats is a proposition, if Sally has 3 cats isn't. So when you're assigning letters to propositions, if you're doing it by, say, circling, you would not circle the word if. If and then are part of the logical connective. They're represented by the arrow. They are not represented by the propositional letters, P and Q. Okay. Next one, if Harry loves Hermione, then Ron will be disappointed. Ron will be disappointed, so Harry loves Hermione. I'll go through these very quickly, but the point here isn't for you to sort of follow at my pace here. I'm just making this video in case you want it. Really what you should do is you should probably go look at the PowerPoint that I'm talking over, which is available in the logic unit, and go through it at your own pace to try and make sense of what's going on. So Harry loves Hermione, that's going to get P. Ron will be disappointed, that's going to get Q, so it has the form if P then Q, P therefore Q, or sorry, Q therefore P. Notice now that this is invalid, right? P then Q, Q therefore P is not a good inference. Think of it like if you're a sister, then you're a sibling so you're a sister. No, that doesn't work. Notice that the other ones we've gone through have been valid. This first one here was modus tollens. The second one here, P, P therefore Q, Q is modus ponens. There's no rule name here because it's not a rule, it's a mistake. So you should label this as invalid. When it's valid, I have it bolded, by the way. And when it's invalid, I don't. So you can see the next one's going to be invalid. Notice we can determine that it's invalid before we even look at the content, just by looking at the form. P then Q, not P, so not Q. Remember, this is the form that pretends that this says P is the only way to get to Q, but this doesn't say P is the only way to get to Q. It just says P is a guarantee that you're going to get to Q. But maybe there's other ways to get to Q. Maybe R gets you to Q. So when you learn that you didn't start at P, it doesn't mean you didn't get to Q, because there may be another route that led you to Q. So learning that P is false doesn't tell you that Q is false. So again, this is invalid. And if you look over here, you can see Juneau is Arkansas is what P stands for. It's warm in Juneau is what Q stands for. And you can see we've broken out this argument up here into 1, 2, and 3. I know that this is a very simple procedure, but it's important that you sort of do it mechanically with the simple procedure before you start to get to complex cases. Otherwise, you'd find the complex cases a little too confusing to grab onto. Next one, if Hermione is a better person than Harry is, then Hermione is less self-indulged than Harry is. If Hermione is less self-indulged than Harry is, then she is more mature than Harry is. Hermione is a better person than Harry is, so Hermione is more mature than Harry is. So here we have Hermione is a better person than Harry is, and that's P. And what I'm illustrating now is that it's important, once you assign a letter to a proposition, to assign that same letter to the same proposition throughout the argument. So we're going to go back and look through and find Hermione is a better person than Harry is wherever it occurs, and make sure we assign it the same letter. Hermione is less self-indulged than Harry is. Well, that occurs there, and it also occurs here, so it needs to be assigned to Q both times. She's more mature, gets R there, so it's going to get R here. And now we can represent the argument in symbols. It goes like this. P, that's Hermione is a better person than Harry is. If P then Q, if P then Q, therefore Q. And then we have if Q then R, that's this one here. If Q then R, therefore R. Now notice I assigned the number 1, P, to this thing down here. You might have thought I had to assign number 1 to the thing up here, but the numbering is arbitrary. The ordering doesn't matter. All that matters is you preserve the logical relationship between premise and conclusion. So long as you treat premises as premises and conclusions as conclusions, the order is irrelevant. Now, you might also have noticed that I draw the conclusion Q here. Q stands for Hermione is less self-indulged than Harry is. But if you look at the argument up here, you're never going to see Q on a line by itself. The only place that Q occurs is as the consequent of this conditional, if P then Q statement, or Q then R. Any statement of if then is called a conditional. The part on the left is called the antecedent. The part on the right is called the consequent. So the only place Q occurs is in the consequent of this conditional and in the antecedent of this conditional. So it never occurs on a line by itself. So why do I have it occur on a line by itself here? Because there is no rule that lets us go from P then Q, Q then R, and P to R in one step. So we needed to break it down. We needed to draw what we called earlier intermediate conclusions. So you may remember there was a slide when I was explaining how to represent arguments that said you always need to draw out the intermediate conclusions. If you didn't draw out this intermediate conclusion and you had just this, P, if P then Q, if Q then R, therefore R, there would be no rule that you could put here that would allow you to go from P, P then Q, Q then R directly to R. So there would have been something that gone wrong if you had said it follows from those 3 premises. But clearly it does follow from those 3 premises. So what do? You add in intermediate conclusions, conclusions that this speaker must have been trying to draw in order to reason well. And that's what Q here represents. It's an intermediate conclusion. So we have P, P then Q, therefore Q. Now we have Q, which is a conclusion, but is going to serve as a premise in the next argument. Q, Q then R, therefore R. And you don't need to label it both conclusion and premise here. You can just label it conclusion. How do you indicate that it's also serving as a premise? Because you've listed it here as where R came from. Okay. Notice that you can also represent this argument another way. And that happens when people don't explicitly state their intermediate conclusions. Sometimes there are multiple ways to represent the argument, both valid and in effect amount to the same thing. So here's another way to do it. You can treat if P then Q as number 1, if Q then R as number 2, and then you can draw as your intermediate conclusion if P then R. That's hypothetical syllogism. It says if you know P gives you Q and you know Q gives you R, then you know P gives you R. And that's what we did here. And then you can take P here and make that number 4. And now we have if P then R as our initial conclusion, which then becomes a premise in the next argument. P right here, therefore R, and that's just modus ponens. So you'll see that the premises match up. It's only the intermediate conclusion that's different. So each of the things in boxes are the premises. They match up perfectly. It's only the intermediate conclusion that differ. And that's okay, because the intermediate conclusion wasn't explicitly stated, so you don't know which way the author was thinking about it. And each one is equally good, so you're not sort of misrepresenting the author or failing to be generous to the author by drawing either intermediate conclusion. Okay, let's look at the next one. If Harry is clever, then he's obsessed with the methods of rationality. If Harry is obsessed with the methods of rationality, then he's in Ravenclaw, but he's not in Ravenclaw, so he's not clever. So we're going to start with Harry is not in Ravenclaw, call that not P. We're going to go to he's in Ravenclaw and call that P. Now, imagine I had called Harry is not in Ravenclaw P. Then when I got to he is in Ravenclaw, I would have had to call that not P. It's perfectly permissible to do things that way. It's perfectly permissible to call a not statement positive and then call the positive statement, the is statement, negative. I prefer, when I have a not, to represent it using the symbol straight away. That way I can, if I find a positive version of the statement, I can always make it positive, and I don't have to mentally keep track of the fact that, hey, way back when I first saw this statement, there was a not, but I called it positive. Now every time it's positive, I have to represent it as negative. I think it's easier to, when you have a not, represent it with the not. But again, you don't have to. The logic is the same either way. Okay, so we're going to look for more of he's in Ravenclaw. We can't find it, so now we're going to introduce a new letter for a new proposition. He's obsessed with the methods of rationality. We're going to call that Q, so we have to go find that wherever it occurs. There it occurs again. And now we just have one proposition left. He's clever. We're going to call that R, and we've got, since he's not clever, is the conclusion not R. So now let's represent the reasoning. We have not P, that's a premise right there. We have if Q then P, that's a premise right there. So together, putting those together, not P and if Q then P gives us not Q by modus tollens, right? Q guarantees you're going to get to P, but you didn't get to P, so you must not have had Q, because if you'd had Q, you would have gotten to P, so we know that Q is false. Now we have if R then Q, so if R then Q, and we do the same exact kind of reasoning, right? R gives us Q, but we don't have Q, so we couldn't have had R, because if we had R, we would have gotten to Q, so we know that R is false. Once again, there's other ways you can do the same thing. You might say, if Q then P, translate that into if not P then not Q. Remember, that's called contraposition, and it says any premise of the form if Q then P is equivalent to if not P then not Q, so you reverse the order and give them both nots. Remember, this is intuitive because this is saying if you start at Q, you're guaranteed to get to P, which is like saying if you didn't get to P, you couldn't have started at Q, because had you started at Q, you would have been guaranteed to get to P. So we could do that. Now we have if not P, then not Q. We can do the same thing here. We have R gives us Q. We can translate that into if not Q, then not R, because again, this says R is guarantees to get you to Q. So if you didn't get to Q, then you couldn't have been at R. Now we can take not P here and input it to not P, then not Q. I've just rewritten not P, then not Q here. And that gives us not Q, right? Not P, then not Q, not P, so not Q. And now we have not Q, then not R. And we're going to input in not Q. That gives us not R. And you'll notice that, again, the premises in the two arguments are all the same. Over here you have not P. Over here you have not P. Over here you have Q, then P. Over here you have Q, then P. Over here you have R, then Q. Over here you have R, then Q. All that's different is the conclusions, right? You never drew conclusion 2 or 4 on this side. So you represent the reasoning a little bit differently. Notice but it's really the same reasoning. Notice also that I have rewritten 2 here and rewritten 4 here, even though I wrote them up here. I didn't have to do that. It was just made it psychologically easier for me to see, right? I'd drawn this conclusion, number 2, and now I have not P, and the conclusion's way up there. So I just stick it here so I can see them together because it makes it easier to draw this conclusion. That's okay. You can rewrite premises just like that. Okay. Now, the next one, either Katara does not criticize Toph or Toph yells at Katara. I guess I should probably stop this video there so it doesn't get too long. We'll continue with that in the next one.